our next one's a little tricky because we have sodium in there. And something to remember about sodium, that's a group 1 element. When it bonds, it's going to form ionic bonds because it wants to form charged compounds, charged species. So when you see an O and A, that means we have an O minus and an Na plus. It's actually a salt. So we'll have that as part of our sketch. So what else do we need to finish in our Lewis structure? We have lone pairs on that oxygen. To make an O minus, we'll have 3 lone pairs to make our O minus. And then these chlorines are going to have lone pairs as well. So let's try and jump right to our hybridization and to our sketch, because this is kind of similar to the ones we just did. This carbon has the 3 chlorines, and the carbon has 4 regions of electron density, so it's sp3. This carbon has 3 regions, so it's sp2. This carbon has 4 regions, the carbon, the oxygen, and the 2 hydrogens, so it's sp3. And this oxygen up here has 1, 2, 3 regions, so it's sp2. I'm not going to do the hybridization when all we have are lone pairs of electrons, because there's really no geometry to show there, because there's only one sigma bond. Okay, so our sp3 hybridized carbon, once again tetrahedral. So we draw 2 bonds in the plane. You could draw it pointing up or pointing down anywhere you want. And then 1 wedge, nice fat triangle there. And then our dash, make sure your dash is showing horizontal lines. Sometimes students draw dashes like this, but that would not be right. That kind of represents a partial bond, so make sure you're drawing horizontal lines there. Okay, so what do we have? We have 3 chlorines, chlorine, 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 and each of those chlorines has lone pairs, 3 lone pairs. The halogens need 3 lone pairs and 1 bond to be neutral and have a filled octet. Okay, and we don't need to show the geometry of those lone pairs, we could just put them on chlorine. Okay, the next carbon we have is trigonal planar, and so we want to do corners of a triangle, 120 degrees, oxygen, carbon, and then to show our pi bond, we show our perpendicular p orbitals, out and back. So there's our pi bond. Our 3D sketch should show our pi bonds in there. And then our lone pairs. Last time we did it as straight lines. Let's show you the other option of drawing the sp2 hybrid orbitals. They look like floppy ears there. That's another way to show the trigonal planar on that oxygen. Okay, now this carbon is tetrahedral. So 109.5 here, and our wedge and dash for our 2 hydrogens. And then this oxygen. Now we need an O minus, so the way you make an O minus is you have a filled octet and with 3 lone pairs, 1, 2, 3, 4, 5, 6, 7. This has 7 electrons, oxygen wants 6, so that extra electron gives it a negative charge. And then the counter ion with this salt is a sodium plus. So when we have an ionic bond, we just draw the plus and the minus next to each other. What we want to resist is the urge to connect them, because that would represent a covalent bond. And this is, in fact, an ionic bond. So we want to make sure we draw that properly. Okay, again, this model, we have our planar sp2 hybridized carbon in the middle here, and then the tetrahedral with the oxygen, and the tetrahedral with the 3 chlorines represented there.